Today in the workshop, we're focusing on the powerful Raspberry Pi Pico microcontroller. I'll show you 3 ways of enhancing the Pico to make it as versatile as an Arduino Uno. We'll also learn how to safely use external power in our Pico projects. Get ready to do some experimenting, and welcome to the workshop. Well, hello and welcome to the workshop, and today I'm going to be trying to break a habit that I have, and it's one that you might have as well. Now, this isn't a bad habit by any means, it's just one that I think could become a better habit, and it goes as follows. Anytime that I get a new sensor device or I see a new library, I want to test it out, and the board that I grab to test it out on is inevitably an Arduino Uno. 9 out of 10 times I reach for an Uno first, simply because the Uno is so easy to use, even though the Arduino Uno is now 12 years old and there are a lot of better and more capable boards out there. What I really should be doing is grabbing a Raspberry Pi Pico. After all, the Pico can run circles around the Uno in all performance specifications. It's a $4 board, and not only can I use C++ and a lot of my existing Arduino code and libraries on it, I can also use MicroPython and CircuitPython with it. It's just a much better choice, but the Uno is easier to use. So I'm going to try to fix that today. I'm going to create not 1, but 3 different versions of the Pico that are very easy to put together. The first one goes together in 5 minutes, and will let you use the Raspberry Pi Pico in as flexible a manner as the Arduino Uno is. So let's start out by comparing the Raspberry Pi Pico and the Arduino Uno boards. The Raspberry Pi Pico was introduced in 2021. The Arduino Uno was originally introduced in 2010. The Pico is powered by Raspberry Pi's own RP2040 microcontroller chip. The Uno is built around the ATmega 328P microcontroller chip. The RP2040 in the Pico is a 32-bit dual-core processor, which also includes a programmable I/O section. The ATmega 328P in the Arduino Uno is an 8-bit single-core system. The Pico is clocked at 133 MHz. The Arduino Uno is clocked at 16 MHz. The Pico has 264 kilobytes of static RAM and 2 megabytes of flash memory. The Uno has just a fraction of that, with 2 kilobytes of static RAM and 28 kilobytes of flash memory. The Raspberry Pi Pico requires a 1.8 to 5.5 volt DC power supply. The Arduino Uno can be powered from a 7 to 12 volt DC power supply. The Pico also has a micro USB power and data connector. The Uno has a USB-B power and data connector. The Raspberry Pi Pico uses 3.3 volt logic. The Arduino Uno uses 5 volt logic. The Pico has 26 digital I/O ports, 16 of which can support pulse width modulation. The Uno has 14 digital I/O ports, 6 of which can support PWM. The Pico also has 3 12-bit analog to digital inputs. The Arduino Uno has 6 10-bit analog to digital converter inputs. And here you can see the connections to an Arduino Uno board. The Uno is ready to use and makes for very simple prototyping. The Arduino Uno is programmed in C++, and you can use the Arduino IDE, the Arduino IDE 2.0, or a different IDE such as Platform I/O. Here are the connections to a Raspberry Pi Pico. The Pico has an advanced programmable input-output or PIO feature. It's also capable of USB emulation. But when you buy a Pico, you're just buying the board. You're going to need to purchase and install some additional connectors, and this is going to mean a bit of soldering. As with the Arduino Uno, the Pico can be programmed in C++ using the Arduino IDE, the IDE 2.0, Platform I/O, or other editors. However, the Pico can also be programmed in MicroPython or CircuitPython, making it much more versatile than the Uno for programming. The Raspberry Pi Pico costs $4 US. A genuine Arduino Uno from the Uno store will cost you $23. However, most of us use clone Unos, and they can be the same price as the Raspberry Pi Pico. The Raspberry Pi Pico can run most existing Arduino code. The Arduino Uno, of course, has an extensive code base. At $4, the Pico is certainly inexpensive, and if you're using clones, the Arduino Uno can be just as inexpensive. The Pico Uno, however, is going to require some soldering before you can prototype with it. The Arduino Uno is ready to use, and even comes with a USB cable. The Raspberry Pi Pico has an extensive amount of documentation created by Raspberry Pi. The Arduino Uno also has an extensive amount of Arduino documentation. There's a rapidly developing base of material for the RP2040 and the Raspberry Pi Pico. And of course the Arduino Uno has an extensive amount of existing projects and tutorials. They're both great boards to experiment with, but today we're going to see what we can do about making the Raspberry Pi Pico as user-friendly as the Arduino Uno board. So here are the two boards that we have facing off today, so to speak, facing off for the contender of being the go-to board when you're experimenting and prototyping. And I've got an Arduino Uno clone over here and a Raspberry Pi Pico, and obviously there are quite a few differences between the two of them. There's an obvious size difference between the two of them, but one thing that we see when we look at the Arduino Uno is the thing that we know and love, and that's all of these female connectors over here, and these connectors will of course make it possible to connect jumper wires, which in turn can go over to solderless breadboards or to sensors, and we can start using our Arduino right away. In fact, speaking of using it right away, when we buy it we also get one of these. It's one of these little USB cables, so we're good to go. All we need is a computer running the Arduino IDE or the equivalent, and we can start working with our Arduino. Now let's take a look at what we get when we get a Raspberry Pi Pico, and this is what we get when we get a Pico. We get the Pico board itself. In fact, when you buy a Pico, if you buy a few of them, you get them on this long strip. They come in this tape strip, and you just get individual little Picos, and as you can see, nothing else comes with them. There is no cable, but if you have a micro USB cable, you can just plug it into the top over here and start using your Pico. Now, there is no power light on this. There's not even a reset button. This is a boot selection button over here, and of course we can't attach anything to it as it is, and so most of us modify our Picos, and we modify them in order to look a bit more like this. And this is a Pico that's had some male pins soldered onto it, and the male pins in turn will allow us to do this, and this is a Pico on a solderless breadboard. And so this kind of duplicates a lot of the functionality that we have with the Arduino Uno. We can have the Uno as we have it over here, or we can have the Pico as we have it here in the solderless breadboard, and we can get at all of our pins with wires and that. So these are both rather convenient arrangements, but there are other methods as well of prototyping with the Pico, and so let's go and take a look at a few of them. So of course I'm not the first person to figure out that prototyping with the Pico could be a lot easier, and there are a number of commercial prototyping products out there that'll make it easier for you to work with the Raspberry Pi Pico, and one of them might be exactly what you're looking for. So before we build our own little Pico Unos, let's go and take a look at a few commercial prototyping products for the Raspberry Pi Pico. So here I have a number of different boards that will allow you to make prototyping and experimenting with the Raspberry Pi Pico a lot easier. Now, over here, the first one we'll take a look at is this Pico Explorer, and this is from Pimaroni, and the way that this works is you insert a Pico into a socket up over here, so you'll need a Pico that you've soldered all the male pins onto, and then it brings everything out for you to a number of different points over here that you can wire to this little solderless breadboard. It's got an OLED display over here. We've got 4 different push buttons for the OLED. OLED display. There's a piezo buzzer, and if you look at the back over here, you will see the diagram as to how all of those things are connected already to the Pico, so you can run some experiments on that and have all these different components already connected for you. So that's a very handy thing. And this is a Pico Explorer by Pi. This one over here is by Citron, and this is a really neat little board actually. I've got one that's already got a Pico already installed on it, but you can also get these with sockets so that you can install your own Pico. And this board brings the Pico out to a number of different connectors. It also brings it out to pins over here, so you can get to the individual pins one by one on these male headers here. It's got a micro SD card. It's got a buzzer inside of it. It's got an LED up over here, an audio out jack, and it tells you right on the silk screening where all of these different components are wired up to. So again, it can make your experimenting and prototyping with the Pico a lot easier. These other two boards from Pi are basically the same thing. There's two different versions of it. This is a Pico Decker, and what you do again is you plug a Pico into here, and it brings all the pins out so that you can add a number of expansion cards to the Pico. And speaking of expansion cards, I've got some over here also from Pi, and these are just basically breadboard cards that you can use to wire your own circuitry to go on top of the Pico. You can also stack more than one of them over here, and this one here is basically the same thing, except on this one you only get to stack two of them. And so a number of accessories that you can use to make experimenting with the Raspberry Pi Pico microcontroller a lot easier. So I think if you were to make a list of the advantages that the Arduino Uno has over a Raspberry Pi Pico, the list would include the fact that the Arduino Uno has a number of female DuPont connectors to connect jumper wires to. The Arduino Uno has a power light, the Arduino Uno has a reset button, and the Arduino Uno can be powered by another power source, such as a 9-volt battery or a wall wart, a 12-volt power supply. And so what I want to do is create some Pico boards that give us the same functionality that the Uno has. Now, you might not need all of those features, and if so, you can create a lesser board. In fact, the first one we're going to look at is something you can literally build in 5 minutes. It only adds a couple of pennies to the cost of the Raspberry Pi Pico, and you end up with something that's just about as versatile as the Arduino Uno. So let's go and take a look at that right now. So once again, we're looking at an Arduino Uno, and at its most redeeming feature, the fact that once you get an Uno, you can just take some wires like these hookup wires over here and plug those wires into the I/O ports of the Uno and start experimenting with it. And you've seen some prototyping methods that we can use in order to get that same kind of flexibility with the Pico. But what I want to show you right now is by far the simplest method of turning this Raspberry Pi Pico into something a little bit like this Arduino Uno. And the simplest method is just to get two of these female connectors over here. That's it, female DuPont connectors, and solder the connectors onto the Pico like this. And I've got one that I've already done that to. And as you can see, this is my handy dandy Pico Uno. It's the simplest Pico Uno you could make, and by far the cheapest. Now, I've also soldered a male connector onto the debug pin. That's an optional thing, and you could have put a female one onto there if you wanted to. But now, of course, I can take all my wonderful jumper wires and connect them up to my Pico. And so my Pico is now as versatile as its cousin, the Arduino Uno over here. And so what you're looking at here is version 1, or the basic version of my Pico Uno, my method of having a Raspberry Pi Pico microcontroller be as flexible to use as an Arduino Uno. And as you can see, I've got a board with a Pico on it. My Pico is currently flashing because it's running the Blink sketch. It's being powered by a USB connection to my computer. And beside the Pico on either side, I've got the same female connections that you have in an Arduino Uno, so I can plug my my jumper wires in anywhere I want and get access to all of the pins on the Pico. I've also got some connections down here, and that's the 3.3 volt output from the Pico. From the Pico's internal voltage regulator, you can use that to power some peripheral devices as long as you don't go over 300 milliamps. And I've got some connections here so I can plug into 3.3 volts and ground here. I've also got some male connections that do the same thing, so I've got quite a bit of flexibility when it comes to powering things up with my Pico. And down here you'll note that I have another LED, and this is a power LED, so I now have a power LED on my Pico to let me know when I've indeed got power here. And I have another switch, and this is my reset switch. Watch the flashing light when I hold down the reset switch. The flashing light stopped flashing. When I release it, it should start again, and that's reset the Pico. And so now I've got both the boot cell and a reset switch. No longer do I need to worry about holding down the boot cell while I'm plugging in the USB cable. I can just hold down the boot cell and the reset instead, so it's a lot more flexible. And so let me show you what I used to build this with. What I used is this board over here, and this is board that is made to emulate a solderless breadboard. So you can see it's got the exact same pattern as a solderless breadboard. The idea is you can take your build from your breadboard and make a more permanent build by soldering onto here. So these holes are all connected in a line the same way they would be in a solderless breadboard, as are these two buses over here. So it made it very easy to wire something like this up. So let me show you how I hooked up version 1 of the Pico Uno. So here's how we're going to hook up a reset button and power LED for our Raspberry Pi Pico. In addition to the Pico, you're going to require a push button, a momentary contact, normally open push button, and you'll need an LED, any color that you like. You'll also need a dropping resistor for the LED, and we're going to use a 180 ohm dropping resistor because we're dealing with 3.3 volts. We'll begin by attaching one side of our reset switch to the run pin, which is pin 30 of the Raspberry Pi Pico. The other side of the switch needs to be attached to one of the Pico's ground pins, and I'm using the ground pin at pin 38. The Pico's 3.3 volt output on pin 36 attaches to one side of the dropping resistor. The other side of the dropping resistor attaches to the anode of the LED. We'll attach the cathode of the LED to ground. We'll also attach the 3B3 out and the ground connections to the power rails on the side of the breadboard. On mine, I also added a couple of capacitors for noise reduction. I used a 10 microfarad and a 47 nanofarad capacitor, but these are optional. Now here's my Pico Uno version 1 with the Pico removed from it so you could see some of the wiring. And the wiring is very simple thanks to the use of this type of a breadboard, because of course all of these pins automatically get connected together when I put the sockets in for both my Pico and the connection sockets outside the Pico. Now you don't technically need to use sockets for the Pico if you don't want to. You could solder this directly to the board, but if you were going to solder it to the board, there is some wiring that you have to do underneath it. So you would either need to have to do that and solder the Pico but not put the Pico all the way down, or you could do the wiring underneath the board. But there are 3 wires to hook up. There's this one over here from my reset switch, and it goes over to pin 30. And then on this end over here, I've got the 3.3 volt output, which I believe is pin 36, which goes over to one of the rails over here, the positive rail, and the ground on pin 38, which goes to the negative one. And then the rest of my components are all down here in the corner. Now I've got the reset switch itself, and since the reset and the LED both need to the ground, they're sharing the same line. That's why they're so close together, but you could place them somewhere else if you wanted to. Here's that ground that they both share being run out to the bus. Here's the resistor, the dropping resistor for the LED, and it's being run to the positive positive side of the bus. And you'll notice I put two capacitors onto the bus. I've got a 10 microfarad and a 47 nanofarad capacitor just across the 3.3 volt bus. And I just like doing that to smooth everything out. But otherwise, the wiring again has been made very simple by using one of these breadboards. It's really just a bunch of female DuPont sockets that have gotten soldered onto a board, and the wiring is kind of already done for you. And so as you can see, in most cases this would suffice to replace an Arduino Uno with a Raspberry Pi Pico in terms of experimenting. However, there is one case where it isn't, and for that we need to look at the more advanced version of the Pico Uno. Now, the two Pico Uno boards that we've built have already turned our Pico into a pretty versatile little device. We can use it in the same fashion we do as the Arduino Uno, plugging jumper wires directly onto the processor board to use in our experiments. But there is one thing the Arduino Uno can do that our little Pico boards can't do, and that's accept an external power supply, something like a 9-volt battery or a wall wart, a 12-volt power adapter, can be used to power up the Arduino Uno instead of the USB supply. Well, we can add that feature onto our Pico Uno boards, but before we add it, we need to learn a little bit about the power pins on the Raspberry Pi Pico. So let's go and take a look at that first. The Pico power pins are all in the upper corner of the Pico board. The Pico can also be powered through the micro USB connector. V-bus is the voltage that comes from the micro USB connector. It will only be active if the Pico is being USB powered, otherwise there'll be nothing on this pin. When the Pico is powered by USB, V-bus is typically about 5 volts. V-sys is the main system power bus. The main system power bus needs to be at a level of between 1.8 and 5.5 volts, and this is the input for the Pico's internal power supply. Now, if the Pico is being USB powered, the 5 volts from the USB will be on this bus, and V-sys will therefore have a 5 volt output. When the Pico is not being powered by USB, we can use V-sys as the input for an external power supply. The 3V3EN pin is an enable pin for the Pico's 3.3 volt internal power supply. Essentially, this is the Pico's on-off switch. Internally, this input will be pulled high with a 100K resistor so that the Pico's 3.3 volt power is always enabled. You can disable the Pico's internal power supply by bringing this input low. 3V3 out is the Pico's 3.3 volt power output. This is the output of the Pico's internal switched mode power supply. You can use this for peripherals, but remember you can only pull a maximum of 300 milliamps here. Now, when the Pico isn't being USB powered, connecting external power to it is pretty simple. An external power supply is connected to the V-sys pin on pin 39, as well as to a ground pin. This external supply needs to be in the range of 1.8 to 5.5 volts. This is the input to the Pico's internal switching mode power supply. This works fine until you plug a USB cable in. You've now got both external power and USB power, which is a situation you want to avoid. Internally, the Pico has a diode that protects the USB port from the external power input, so there's no danger to the USB-powered device. However, when USB power is connected, the V-sys pin is now an output and is feeding voltage back toward your external power source. That external power source is unprotected. The simplest way to protect an external power source is to add a protection diode. The best type of diode to use here is a Schottky diode due to its low forward voltage drop. The diode will provide some reverse current protection and will avoid the situation in which the USB power is attempting to charge the external power source. Even using a Schottky diode, however, there is some voltage loss with this system. A more advanced system of protecting an external power source is to use an electronic switch. This external switch can be triggered by the V-bus pin, which, as you'll recall, will go to 5 volts when a USB power source is attached to the Pico. You want to have your switch to go off when it detects that V-bus is at 5 volts. An arrangement with an electronic switch will provide a very minimal voltage loss for the external power source. An ideal component to use for this type of switch would be a P-channel MOSFET. Unlike the N-channel MOSFET that we normally use in most of our designs, the P-channel will turn off when 5 volts is at the gate, which is exactly the operation we want. So as long as you heed the warnings about using external USB power at the same time, you can definitely supply external power to the Raspberry Pi Pico. So now that we understand the power considerations, it's time to build the ultimate Pico Uno, one that has a jack on it to allow for external power. Now, a couple of things about the build that I made. First of all, I used another Proto board for it, not the same one that I used in the Pico Uno with the reset switch, but a similar one. It also emulates a solderless breadboard, but it has a place on it to allow external connectors, including a 2.1mm power jack. So I used it because of this feature, but you could use the same board I used to construct the Pico Uno that just had the reset switch and the power LED, and it would work fine. There's enough place on there for a 2.1mm power jack, or whatever power jack you want. You don't have to use the same type of power jack. In a similar fashion, you don't need to use the same buck converter that I used. Now, I used the Mini 360, which is a very common buck converter. It's very inexpensive. You can get it on Amazon or eBay, but they also have a lot of other suitable buck converters. You could also use a 3-pin linear regulator, because that's after all what they use in the Arduino Uno. So you don't have to feel that you're glued into using the exact parts that I used. So with that all said, let's go and take a look at the ultimate Pico Uno with an external power input. And so here we have version 2, or the deluxe version of the Pico Uno. Now this will do everything that the Uno will do, and as you can see, it's doing one thing that the Uno can do. It is being powered by an external power supply. So right now I've got a 9-volt battery plugged into a barrel connector over here, but I could also have used a 12-volt wall wart if I wanted to. And you can see my Pico is flashing again, because once again it's running the blink sketch. And otherwise, this is identical to the previous version in that we have a reset switch over here. So if I hold that down, you can see I've reset, and there we're going again. And I've also got a power LED here, and this can be powered by either the USB connector or by an external voltage on the connector over here, and the voltage range is pretty well the same range as it is for the Arduino Uno. And so there you go, the deluxe version of the Pico Uno. Now let me show you how you can build one. Now here are the parts that I used in order to construct the deluxe version of the Pico Uno board, and like any of these boards, you can make use of things that you already have, or you might want some additional enhancements to it. It's your project. But what I built my project around was this board over here. Now this is similar to the solderless breadboard emulator circuit board that we saw earlier. That's exactly what it does over here. It's again emulating a solderless breadboard, but it also has a place up over here for a couple of common components, and one of them is a barrel jack, and that's why I chose this board. I got this on Amazon. I've seen a few different ones on eBay with different components you can get. So if you can find something like that that already has the power jack, you can go ahead and use that. Otherwise, you could use the exact same board as we did for the last design. If we take a quick look at the last design over here, there is plenty of space on here for a power connector and for the voltage regulator, so you could build it on this as well. But I thought that this board that had the place for the barrel connector right at the front over here was a lot easier. Now these are the other components you're going to need to build it. You're going to need 4 20-pin female connectors. You're going to need a couple of smaller female connectors for the power bus, and also some male ones that you can cut down to size for that. Now this is the voltage regulator that I use used. It's the Mini 360 voltage regulator. You do not have to use the same regulator by any means. There are a number of other things you could use. You could use another small buck converter module like this one over here. You could also use a analog, a linear voltage regulator, and just use one of the 3-pin regulators. That would work just fine. In fact, that's what they use in the original Arduino Uno. So anything that can bring the voltage down to about 5 volts is what you want over here. I've got my Schottky diode over here. It's best if you can use a Schottky diode. You'll get better performance out of it, and you'll get a lower voltage drop across the diode, so it won't run as warm. But you could also use something like a 1N4007, and that would probably work just fine. My 2 capacitors, my two 10 microfarad capacitors, my LED and the dropping resistor for the LED, and a 47 nanofarad capacitor. And one of these capacitors here and the 47 are just to go across the supply voltage, and the other one is on the output of the buck converter slash diode arrangement. It's just the voltage output that goes into the VSys on the Raspberry Pi Pico. And so these are all the parts that you need to put something like this together, and otherwise the wiring is very similar to what we did before. But let me show you what enhancements you have to add in order to add external power onto your Pico Proto board. So to build our advanced Pico Uno with the external power supply, we're going to begin with the exact same circuit we used for the Pico Uno we built that had the reset key and the LED for power. So you can use the same board that you've already built or start a new one. In addition to those parts, you're also going to require a voltage regulator or buck converter that can have an input of somewhere between 7 and 12 volts and produce an output of about 5 volts. Now I used a Mini 360 buck converter, but you can use a different buck converter, or you could use a 3-pin voltage regulator. You'll also require a power jack. I used a 2.1 millimeter barrel jack, but you could use whatever power plug makes sense to you. We'll require a diode, and I used a 1N5817 Schottky diode. You could use a different diode if you wish, as long as it can handle a current of at least 1 ampere. And we'll require a 10 microfarad capacitor. We'll begin by connecting the ground connection of our power jack to the regulator's negative input. We'll take the power jack positive terminal and connect that to the regulator's positive input. The regulator's negative output will be connected to our existing ground system. The positive output of the regulator will be connected to the anode of the diode. The cathode of our diode will go to the Pico VSys pin, which is pin 39. We'll also connect VSys to the positive side of our capacitor, and we'll connect the negative side of our capacitor to ground. And this completes the wiring of our advanced Pico Uno. So here's my deluxe Pico Uno with the Pico taken out of it, so you can take a peek at the wiring that goes on underneath the Pico board. Now, a lot of the wiring is the same as what we used in our previous design, and the one that just had the reset switch and the power LED. And so that would be the same wiring over here that we have going to the bus, and that just moves over down to here. Pin 36 is the 3.3 volt out, and pin 38 is the black one, the ground out. Now these connections over here are the ones that come from the barrel jack, and they run over to this point on the board. They also have a equivalent point on the other side of the board here that they run to, and so I'm running those down to the input of my power regulator, my buck converter, the Mini 360 that I'm using. Now again, you could be using a different converter, or you could use a 3-pin linear regulator over here. You'd still need to run the power down to it. And on the output here, I'm not sure if you can see it because it's black on a black background, but my diode is buried back over here, as is the capacitor that's on the output. And then the rest of the components are the same components that we saw earlier, the 2 capacitors that I put across the power bus, the resistor I'm using as a dropping resistor for the LED, and the push button switch and the LED are sharing a common ground, and that wire goes down over here. And so the wiring again is been simplified by use of a breadboard that already is pre-etched in a pattern, and again the pattern being the same pattern as a solderless breadboard, so it makes all of this wiring over here a lot easier. You don't have to make the 40 different wiring connections out. You just have to put these down on the board and solder it as if it was a custom designed printed circuit board. And what you end up with is a really handy way of experimenting with the Raspberry Pi Pico, a way that makes it as easy as using an Arduino Uno. Well, at the beginning of the video, I said I was trying to break the habit of always grabbing an Arduino Uno every time I needed a board to test something out with. And I think with our last couple of iterations of Pico Unos that I've found the board that I'll be using. So I'm sure you're going to be seeing a lot more from the Raspberry Pi Pico and other RP2040 boards here in the DroneBot workshop. Now, if you want to get the schematics for our Pico Unos or get some more information about the Pico Power, you can check out the article that accompanies this video, and that's on the dronebotworkshop.com website. There's a link right below the video to that article. And while you are out there reading the article, perhaps consider subscribing to my newsletter. It's not a spam letter, of course, and it's not a sales letter, just my way of letting you know what goes on here in the workshop. And when you're on the website, you'll find the link to subscribe to that newsletter. If you want to discuss the Pico Uno or the Pico in general or anything else electronic, well, head over to the DroneBot Workshop forums, where you'll find over 3,500 other people who love to discuss electronics with you as well. And the forum is free to join. There's a link to the forum right below this video. And finally, if you have not subscribed to the YouTube channel, please do. I make videos pretty consistently these days about electronics, microcontrollers, things like the Arduino Uno and the Raspberry Pi Pico, and a lot more. And to subscribe, all you need to do is click on that red subscribe button. And if you also click on the bell notification, and assuming you have notifications enabled for YouTube, you'll get notified every time that I make one of these videos. So until we meet the next time, please take good care of yourself, please stay safe out there, and I will see you again very soon here in the DroneBot Workshop. Goodbye for now.